Welcome to For Your Information, How It Works, Brushless DC Motor. What is a brushless DC motor? BLDC is a permanent magnet synchronous motor that runs on a DC supply. BLDC motor commutation is controlled by an electronic controller instead of mechanical commutation. BLDC motor employs electrical commutation with a permanent magnet rotor and a stator with a sequence of coils. In this motor, the permanent magnet rotates and current-carrying conductors are fixed. The armature coils are switched electronically by transistors or SC are at the correct rotor position, in such a way that the armature field is in space quadrature with the rotor field poles. Hence the force acting on the rotor causes it to rotate. Hall sensors or rotary indicators are most commonly used to sense the position of the rotor, and are positioned around the stator. Construction of BLDC motor. BLDC motors can be constructed in different physical configurations. Three-phase BLDC motors with permanent magnet rotors are most commonly used. The stator of a BLDC motor is made up of stacked steel laminations to carry the windings. 1. Rotor. The BLDC motor incorporates a permanent magnet in the rotor. The number of poles in the rotor can vary from 2 to 8 pole pairs, with alternate south and north poles. To achieve maximum torque in the motor, the flux density of the material should be high. Ferrite, samarium, cobalt, sumco, neodymium, Nd, and ferrite and boron. Info. 2. Hall sensors. Hall sensor provides the information to synchronize stator armature excitation with rotor position. Since the commutation of the BLDC motor is controlled electronically, the stator windings should be energized in sequence to rotate the motor. Working principle of BLDC. BLDC motor works on a principle similar to that of a conventional DC motor. Lorentz force law states that whenever a current-carrying conductor is placed in a magnetic field, it experiences a force. When the stator coils are electrically switched by a supply source, it becomes an electromagnet and starts producing the uniform field in the air gap. Though the source of supply is DC, switching generates an AC voltage waveform with a trapezoidal shape. Due to the force of interaction between the electromagnet stator and permanent magnet rotor, the rotor continues to rotate. BLDC drive circuit. As described above, the electronic controller circuit energizes appropriate motor winding by turning the transistor or other solid state switches to rotate the motor continuously. The figure below shows the simple BLDC motor drive circuit, which consists of a MOSFET bridge, also called an inverter bridge, electronic controller, Hall effect sensor, and BLDC motor. Here, Hall effect sensors are used for position and speed feedback. The electronic controller can be a microcontroller unit, or microprocessor, or DSP processor, or FPGA unit, or any other controller. This controller receives these signals, processes them, and sends the control signals to the MOSFET driver circuit. Applications of BLDC. 1. Computer hard drives and DVD, CD players. 2. Electric vehicles, hybrid vehicles, and electric bicycles. 3. Industrial robots, CNC machine tools, and simple belt-driven systems. 4. Washing machines, compressors, and dryers. 5. Fans, pumps, and blowers. Advantages and disadvantages of BLDC. Advantages. It has no mechanical commutator and associated problems. High efficiency due to the use of permanent magnet rotor. High speed of operation even in loaded and unloaded conditions due to the absence of brushes that limit the speed. Smaller motor geometry and lighter in weight than both brush-type DC and induction AC motors. Long life as no inspection and maintenance is required for the commutator system. Higher dynamic response due to low inertia and carrying windings in the stator. Less electromagnetic interference, quiet operation, or low noise due to the absence of brushes. Disadvantages. These motors are costly. The electronic controller required to control this motor is expensive. Not much availability of many integrated electronic control solutions, especially for tiny BLDC motors. Requires complex drive circuitry. Need of additional sensors. Thanks for watching. For more informative videos, please subscribe and like. Also click the bell icon for new video notifications.